In the previous lectures, I derived the timescale for the migration timescale for a particle to fall to the central stars. We use a Hayashi model to estimate the migration timescale for a solid particle. First topic is the migration of a small particle. Relaxation time of the tau s is much shorter than the Keplerian time of the t sub k. We expect St should be the much smaller than the ones. Then we'd like to calculate. Definition of the St is mu times omega sub k over fds. Drag force for this regime is expressed this one. Then you can substitute this f into this equation. We'd like to introduce the density of the materials of a solid particle of the rho sub p. This is density of the solid particles. If we consider the solid particle with a radius of the r sub p and the density is rho sub p, and total mass can be calculated. Volume times the densities, rho sub p times 4 pi over 3 r sub p cubed. So actually this factors becomes equal to the 1 times r sub p over r times rho sub p over rho times v sub k over c. Then we use a Hayashi model. Hayashi models show the density of a gas is expressed 1.4 times 10 to minus 9 gram per cubic centimeters and R over 1 AU. And the power index minus 11 over 4. And the sound speed is expressed 1.0 times 10 to 5 meter per second. R over 1 AU minus 1 over 4. Sound speed is a decreasing function with a distance from a central object. Then we substitute this quantity into this equation. Then we could find that St, as we expected, Stokes number is much smaller than 1, 4.3 times 10 to minus 7. Then migration time scale is expressed this one. We consider the St is much smaller than 1. The St is going to be cancelled. It becomes R over St eta v sub k. And the St is proportional to R sub p. Then tau is proportional to 1 over R sub p. If you increase the size of the solid particle, migration time scale is decreasing with the size. If you consider the very small particle of the 1 micrometers, migration time scale is really long, 100 million years. If it's increased to 10 centimeters, migration time scale becomes 10 to 5 years. Then we consider the migration of large particles. Gas drag for a large particle. In this regime, drag force acting on the solid particle is expressed this one. Then you can substitute drag force into this equation. U, difference of a solid particle velocity with respect to the gas velocities. It becomes 1 over 2 eta v sub k. Then you can substitute this u is here. Then, as we expected, St becomes larger than 1, about 10,000. So this is much larger than 1, because large particle takes a longer time to follow the motion of the gas, because the gas drag is too weak to change the orbit of a large particle. Then migration time scale. St is much larger than the 1, so you can ignore the second term. 1 over the St is cancelled. So 2St over eta v sub k. The St is proportional to R sub p. So migration time scale is proportional to the R sub p. Then if you draw a graph, horizontal axis is the size of the solid particles. Migration time scale is an increasing function with respect to the size of the solid particles. If you consider the really big object of the 1 kilometers, it takes 1 million years for a particle to migrate to a central stars. But if you consider a small object, 1 meters, it takes only the 1,000 years. Then, if you sum up all the information, this is the migration time scale of a particle from the 1 micrometer to the 1 million meter. So 1,000 kilometer particle. We just only consider the migration time scale for particles at R equal 1 AU. Then small particles move with gas, while large particles are not affected by the gas drag significantly. Particles with a meter size migrate quickly in a disk in 100 to 1000 years. In intermediate regions, the particle takes only 100 to the 1000 years. Lifetime of a disk is estimated as a few million years. Yellow shaded regions represent the time less than the lifetime of a disk. It is important to consider the formation mechanism of a large particle in such a short time scale. So we need to leap the small particle to the large particles. Some mechanism to form a large particle quickly from the really small particle. Otherwise, solid particle in a disk quickly migrate to a central star. This is one of the serious problems we have to solve in the theory of planet formation. Okay, so this is the end of the chapter 5.